Okay, so for question 5, a class of 20 students sits for exams in English, accounting and maths. So you have two correlation coefficient here. Between English and accounting is negative 0.89. Between maths and accounting is 0.7. So between these two, what you can see is between English and accounting, the relationship is stronger than between maths and accounting. It doesn't matter whether negative or positive. But between English and accounting, there's a stronger relationship compared to maths and accounting. So if I want to make any prediction, the best would be between English and accounting. So one student got 60% for English and 61% for maths, did not sit for accounting. If you had to predict which one would you use, of course you will use between English and accounting, alright, because the relationship is stronger. So if you want to predict, you will look for a stronger R. Alright, question 6. There are 10 cars in the display area of a used car yard. The age of the car is marked below here. You have it. So it's between A and P here. You're supposed to plot a scatter plot. That shouldn't be a problem. You're supposed to find R. You can ignore all this since it's a table. Just put it into the calculator and calculate. Okay, and they've asked you comment on the results obtained. Alright, there is a strong positive between what and what. Alright, now okay, so now if they ask you for significance, then it is older cars are cheaper compared to newer cars. Why? Because you can see it's a negative, right? A negative relationship shows as the age increase, the price decrease. And I think by now you should know what that means, right? The older the car, the cheaper it should be. Alright, so estimate the correlation coefficient for the price of the car versus the year of manufacture. So now let's look at this, okay? This will be a little bit complicated. It may take a little more time, but you will get it. So just now, between age and price, what we calculated together was negative 0.82 between the age and price. But between the age and year is negative 1. Remember doing perfect relationship just now? Between age and year is negative 1. Okay, why negative 1? I showed you during the perfect relationship, as the year increased, age will decrease. Alright, so between year and price, since these two is a perfect relationship, anything between this and this or this and this, the relationship strength will be the same, 0.82. Is whether it's positive or negative, only it will change. So between year of manufacture, if the year of manufacture increased, that means the newer the car is, the higher the price. Both are moving in the same direction. Therefore, it's 0.82. This will be a little bit complicated for you to understand for now, but you will get it slowly, alright? So between age and price just now is negative 0.82. Between age and year, it is negative 1. A negative 1 I have explained to you just now already. Okay, when we did the age and year in perfect relationship. So because these two is perfect, so anything between this, the relationship value will be the same. Between age and price, year and price, it will be the same because these two is perfect. So it will be 0.82, but the difference is it's no more negative, now it is positive. Okay, question 7. I think this is pretty much quite direct. Find the correlation coefficient for this between mother and son. You put everything in, you get 0.18. The heights were also collected 2 years earlier when their sons were 15 years old. The correlation coefficient was approximately 0.2. Comment on both. There is no significant relationship. Okay, so this is quite direct. Okay, calculate the correlation numbers for the pairs on each of the scatter diagram. Basically, you're going to take out the coordinates one by one and just plug everything into the calculator. This shouldn't be a problem. Like this point is what? 1, 2. This point is what? 2, 2. This one is what? 1, 3. So you write down all the coordinates and just put it into your calculators and compute the value. Alright? Question 9. A male athlete is a specialist in the 100-meter sprint. Could the weight related to the time? So when you put all this into the calculator, you can see there is 0.1. It's quite simple actually. Just use the calculator and calculate. Would it be possible to predict the best time with a weight of no? Is not possible. Why not possible? First of all, there is no linear relationship between this, so prediction is not possible. Alright, population and price. okay, of a hotel room. Is there a linear relationship between these two? So how would you basically know if there is a linear relationship? You need to basically plot the scatter diagram first and foremost. There you can see it here. The scatter diagram is plotted down for you here, the original one. And then if you calculate the R, what would you get? 0.17. There is no significant linear relationship. Okay, sorry, yeah, this is before the removal, the scatter diagram between X and Y, which is you get 0.71, a strong relationship. But after you remove C, you will see you get RXY 0.17. There is no significant linear relationship. Okay, and if they ask you about what's the effect of outliers, outliers will give false relationships. Okay, question 11. Okay, I'm just going through it. What you can do is later you do it one by one. You can pause the videos and do it as we move along. So the last one, I've asked you to draw the scatter diagram. You just draw the scatter diagram as usual. My scatter diagram don't have the mean point here. Please make sure yours has. Covariance, you cannot get it from the calculator. You have to do it manually. Okay, but sigma xy is in your calculator. To calculate covariance, you need sigma xy. Sigma xy is in your calculators. All right, don't know how to find it, just ask me. For the black calculator, shift 1, it is there, sigma xy. For the silver calculators, you look for sum, it is there. All right. The manager of the supermarket then said, the hotter the day, the more ice cream people buy. Do you agree with this? No. Why not? Because there is no linear relationship between X and Y. You want to write X and Y, so no problem. Alright, so with this, I think you should be quite sorted with 2.1. If there are any issues, just let me know.